So welcome, and I totally realized that this presentation is standing between you and lunch, so I'll try to do my best to make it as exciting as I possibly can, and I'm sure that that my co-speaker today, Sascha Bates, is going to do the exact same thing. By the way, if you're wondering who I am, and obviously I have the obligatory introductory slide, assuming that my clicker is going to work at some point in time. Yes, exactly. So my name is Stigter. I'm a developer advocate, and I'm passionate about things like serverless, containers, and generally all things cloud. So as long as you can deploy it to the cloud, no matter what it is, I get excited about that. Interesting thing about me, I love dad jokes, cheesecake, and API. So last night's, by the way, who was at the gala dinner last night? That dessert was totally for me. I loved it. Did everyone else enjoy it, by the way? Good, good. So today we're going to be talking about serverless, and the first question is, what actually is serverless? I mean, in the end, it still does use servers, doesn't it? The answer to that, by the way, is yes, it absolutely still does. So just out of curiosity, who is using serverless today? So any type of serverless technology? Cool, I see a few hands, and I know this is totally going to annoy the people recording, but what kind of technology are you using for it? AWS Lambda, or?
Yeah, AWS Lambdas.
Cool.
Other technology.
Yeah, awesome, awesome. So anyone not using AWS Lambda? I mean, the ones who raised their hand for I'm using serverless. So pretty much everyone that's using serverless today uses AWS Lambda. And I mean, I love that. I love Lambda as well. And I know that Sascha is going to talk a lot about Lambda at her company. But if you look at what serverless means, then serverless, and I obviously took this from a great AWS reInvent presentation, where they talked about serverless is an operational construct. And it all depends on where you are in terms of operation and what type of artifact you want, where you fit within that spectrum. So you could absolutely say that things like, and I hope this is somewhat readable, that things like Lambda, absolutely serverless. I mean, that is totally on the less operation side of things, because as a developer, when I deploy to Lambda, I don't have to care about anything other than just writing my code. And I mean, that's the beauty of Lambda, isn't it? But at the same time, things like EKS or ECS, or to some extent even EC2, is all about being serverless. Because serverless, at the end of the day, to me means, as a developer, I don't have to worry about the server. Someone else is going to do that for me. And if you look at it, serverless is generally built on 4 principles. And the first, as I just talked about, there are no more servers to maintain. So the beauty of serverless for me as a developer is that I can deploy anything that I want to anywhere that I want without being bogged down by thinking, is the server that I'm going to deploy this to, is it going to be able to take care of the load? Is it going to be able to take care of what I want to deploy, where I want to deploy? Because my app that I'm building might be so super successful in Europe that I want to deploy closer to where my audience is. Second one is automatically scale with usage. So as my app gets more popular, I totally want it to scale up to as many instances of whatever it is I'm deploying that I need. When I'm using AWS Lambda, I want it to scale out to thousands, hundreds of thousands of functions simply to sustain the workload that I have. But at the same time, when I am not using it, I also really want to make sure that I am not paying for something that I'm not using. I mean, I am Dutch, so I really want to make sure that I get to pay for value. I get to pay for what is important to me, and free is always better. I want to make sure that I'm paying for what I'm using. I want to make sure that I'm not paying for server units, because that is not how I think as a developer. Who here in the audience is a developer? I mean, who writes code for a living? Good. So who of you think about server units? Okay, I see a few hands. Okay. Most of you don't, and that is absolutely okay, because you think, I hope you think in terms of how do we get business value to the people that we serve, to our business people. And the last, but definitely, or one of the most important ones, is availability and fault tolerance built in. The worst thing that can happen as you deploy your app is that it goes down on Saturday night. Obviously, that is at peak time, 2 a.m. in the morning for you, because someone else on the other end of the world is using it, and they are going to call you. Who has ever had that phone call at Saturday night, 2 a.m.? Exactly, I see a few hands. That is not what you want to happen during your weekend, right? Okay, just making sure. I mean, there might be people that actually enjoy that. So as I've been talking about this, some of you who use the JFrog technology might actually be wondering, what does JFrog has to do with that? I mean, isn't JFrog like this on-prem thing, maybe a little cloud? And the answer to that is perhaps we are. But as you've been listening to all the announcements yesterday and today about things like JFrog pipelines, things like the partnership that we have with VolnDB, the things that we do with Artifactory in general, then it should hopefully be clear that as you think about moving to serverless, as you think about moving to cloud, as we just talked about some of those 4 constructs, that Artifactory and I would almost say the total suite of JFrog products still plays a very big part in that. Now, we can do 2 things, and I'll let you decide. We can either go through a few more slides, or we can do a live demo. Hands up for slides. Hands up for live demo. Good, I was kind of hoping that. Cool. So let me end this show and go over to Visual Studio Code, which is personally one of my favorite editors. And I hope you all can see this. I hope this is like large enough for people to actually read. If not, let me know. Then, okay, I see some people nodding in the back. That's awesome. So what I'm going to do is, because I know that Sascha's going to talk a lot about AWS Lambda, I'm going to use a different type of construct. I'm going to use a project called Faas, which is essentially serverless based on Kubernetes. So what I'm going to do first thing is I'm going to download a few templates because I really want to make sure that I'm using the right stuff. So Faas CLI, template pool, and I built my own template, so I know that this is absolutely going to work, and I created one specifically for Artifactory. So specifically, to really make sure that I can trust where my dependencies are coming from, I created this template. So I'm going to do Faas CLI, new, and I'm just going to call it demo. So it's going to create a bunch of things for me, cd demo, awesome. So essentially what it did is it created a handler file for me, which you can see. And I'm using Golang, by the way, simply because that is the language that I prefer. You could absolutely do this with any type of other language that you prefer. So this is just a basic handler using a few basic modules that Aaron Schlesinger was talking about. Now, first thing I'm going to do is I don't like my function, so I'm going to give it a slightly different name, github.com/redkits, which is my GitHub handle, and I'll call it holidays because that is absolutely what we care about. So next thing, save, obviously. So one of the things I want to do is get my dependencies, and the dependencies you get always from the internet, right? Okay, I was kind of hoping that someone would stand up and say, no, we need this from Artifactory. Thank you. Okay, so we need this from Artifactory, exactly. So let me get a Go module, and I'll get one of my personal favorites, and they are absolutely prefaced by github.com because that is where the code lives. Check ID, which is basically a wrapper around a holiday website, so I can see what kind of holiday today is. So in order to use that, and by the way, when I did that, if you're familiar with Go, you can see that it just added it here as one of my dependencies. So right now, I can, well, I don't need this message, so I'm going to delete that. And what I'm going to do is, well, I don't actually want a specific date. I actually just want to have today. So what I'm going to do is I'm going to reach out to their website, going to download all the holidays of today, and that is what I'm going to be showing as my payload. That's going to come back. The other thing I need to do is make sure that it imports github.com/redkits/check ID. Awesome. Okie dokie. So next thing that I get to do, and I'll speed it up a bit so that I don't take any more of Sascha's time, is I can actually run the Faas CLI up command. And what this will do is it will essentially create my Docker container, will download all the things it needs from Artifactory, and we'll look at how that looks in Artifactory. It will create a build for me. So who is familiar with build info in the Artifactory world? Okay, awesome. So I see a few hands not being raised, so we'll look at that as well. So this is going to run. Oh. And that obviously should have been demo.yaml. Oh. Cool. And then let's go to Artifactory, because this is actually where the magic happens. So if you go into things like Artifactory, then you obviously have your repositories here. And as I look at the stuff that I have in here, this is where my artifacts are coming from. This is where my GitHub my Go modules come from. So everything that I do, even though I'm deploying to a serverless platform, everything is powered by Artifactory. So that also means I know exactly which versions. I know exactly which licenses. I know exactly what goes on in my Docker container. And as I look at my builds, then I can see what was being built, what is used, all that kind of stuff, so that as a serverless developer, as a developer caring about serverless technology, I still need to know what am I using, what are my dependencies, where is it coming from, what are the licenses? Because at the end of the day, someone has to take care of that I'm doing the right stuff, right? Anyone here seen the talk yesterday with our general counsel where he was talking about licenses? That is absolutely important. That stuff is fundamental to being able to deploy apps, and whether that's serverless or not, that is critical. So by now, it should have been deployed, and as I go to my holidays function, it is ready. I obviously tested it a bunch of times. And as I hit invoke, and I'm doing this through the UI so that you can actually see UI instead of just a bunch of lines of code on a text editor, as I hit invoke, it's actually going to show me all of the special days that today are. And I'm guessing that my two favorite, at least for today, are the National Eat an Oreo Day and the National Martini Day. So right after the presentation, I'm going to go down to the bar, eat an Oreo, drink a martini. So these are things that will obviously help you as you start to build serverless. And as I said, serverless is not just the Lambda stuff. It also is about containers and how you think about running all of that on, in my case, AWS. So I totally realized that being in serverless and thinking about containers also means that you want to be thinking about Lambda. Because I kind of did containers, but I also kind of want to function as a service, the whole Faas idea. So I'm very happy today that I'm going to be joined by an amazing speaker, someone that we've been trying to get here for years, and she'll obviously talk about that a bit. So Sascha, if I can invite you on stage, please.
Thank you, sir.
Thank you.
It's a good thing now that I didn't get a beer because I don't have any hands.
That's probably
because I have to hang onto the microphone. I would just be sad and have to look at the beer. All right, so this is me. I'm Sascha Bates. I work now these days for Slalom Build. I'm a solution architect there, and I have been working for the last year and a half or so on serverless, Lambda, pipelines, mostly Jenkins. I'm known in the community, or at least in the past, I have been known for things, especially for my love of automation, many lolcats in my presentations at conferences, and my mad love for Chef, which I've spent many years working on prior to what I'm doing now. These days, I'm mostly known for being too lazy to go to conferences and too lazy to write talks. But, so why am I here then? Literally, Baruch asked me to come. So I have been a fan of Baruch and JFrog for several years because I was sad one day in 2012 because I couldn't get the checksum I needed for Chef. And so I was sad about it on the internet, as one does. And overnight, because he was in Israel, Baruch fixed my problem. He made me a plugin in Artifactory that let me download the checksum size that I needed from my file checks for Chef. And I have been a huge fan of his ever since. And so that's specifically why I'm here, because he asked me to come. And I actually have really interesting things to talk about now that I have been working on some new stuff for the last couple of years. So serverless is a huge part of that. I've been doing mostly AWS Lambda work for the last year and a half, although I've also written a pipeline around AWS Fargate. When I'm not tearing my hair out or raging at 2 a.m. because there's things not doing what I want them to do, I'm having a lot of fun. I've really enjoyed doing the pipeline work, trying to figure out how to automate Lambdas and all of the serverless infrastructure around it. And pipelines, because I love pipelines. They are, I have this thing about putting stuff in order and building out really nice, informative things, because a lot of times, especially like when you're working with a dev team, they feel kind of, I don't know, lost and uninformed. So I really enjoy actually building things that automate a lot of the work for people and our managers, of course. So that's why I'm here. So I'm kind of curious to know why everybody else is here. You don't actually have to raise your hands, but it would be cool if you did, because I am genuinely curious. So how many folks are, help, I hit the wrong button. How many folks are just getting started? Nobody? Maybe? Okay. How many of you are hopelessly in the weeds and feel like you're never gonna climb out? Because I've had some of those 2 a.m.s. I'm still up and committing one-line changes to my pipeline at 2 a.m. because I can't make it do anything, and the only way to test my changes is to actually kick off a pipeline, which is some of the hardest feelings in the world. So next, how many of you have already been there and done that and hoping I have something new and interesting to tell you? All right, probably not, but maybe. And then there's the, do you just like pipelines? Right on. Because I do too, right? The big reveal, I always like to know ahead of time what people are going to talk about, so I'm not wasting my time. Because I get really annoyed thinking that a thing is going to happen and then nothing happens that has anything to do with what I'm interested in. So this is the big reveal at the end of the book. This is what we will have talked about, at least at some level. So we use Lambda with API Gateway mostly. We use AWS SAM to deploy and manage it. Our backend services are mostly written in TypeScript and JavaScript. And I use a Jenkins scripted multi-branch pipeline mostly. I've also done some tinkering with code build and code pipeline. And we have some code that I haven't written for Bitbucket pipelines as well. So, I mean, there's a collection of stuff, but my expertise area right now has been the Jenkins multi-branch pipeline. Also, your mileage may vary with what I have to say, because I work for a consulting company. We are dev teams that can continually iterate and greenfield, right? So we can greenfield something and then be like, oh, well, that didn't work at all. I have no idea what I was thinking. Let's do it different on the next project we start in a couple of months, which is great for me, not always great for folks who actually have real lives, real jobs, and can't be starting over all of the time. So I am going to try and keep my talk as relevant as I can. And I'm sorry if I'm too off in the green fields and that is not what you're looking for. I mean, we still do projects for a year or two sometimes. So we still do actually have to live with the consequences of our choices. It's just that we can actually make changes quite a bit to how we want to do things. A little bit about how we work. We work in pods. So when we have a client or a project, we start with a pod. And we start with a solution owner who is pretty much our scrum master, cat herder, everything person. And we love them because they do all of the work that the rest of us hate doing, so that we can just pretty much sit down, write code, do things that we want to do, and not worry about other stuff. We have a dev lead. We generally have 2 to 3 devs. And we generally have 2 to 3 quality engineers as well. So we always have people who are there to specifically write automated testing for the apps that we're writing. And then we have one of me, basically, the cloud automation, all the things that aren't the code person. And we generally work in a roughly cross-functional manner, although we don't pair, and so we still have a bit of siloing within our teams. But in general, we're pretty collaborative and cross-functional, and that really helps a lot with trying to produce the apps that we're trying to produce. So how we work, our core beliefs. I'm actually really lucky. I've been with Slalom for almost 2 years now, and I'm constantly stepping on the step that's not there of thinking I'm going to have to argue with people about what I want to do with project work, right? So we believe that we partner with our clients. We always have people integrated in our projects that are from our clients. So we don't deliver empty code in a box because we know that that generally fails. We automate everything. We believe in trying to automate everything. Sometimes we have to do it by hand first, but it always gets automated. We prefer short-lived feature branches. Some of them are a couple hours, couple days. None live beyond the end of the sprint, which is generally 2 weeks. We love testing. We write a lot of tests. We don't manual gate in our pipelines, ever, unless we have a really good reason to do it. We write a lot of test automation. Did I say that already? Pure code reviews, at least 2 approvals, generally 1 dev, 1 QE. We also write tests. We build once and deploy artifacts everywhere. And we all believe that sprints should end on Wednesday. We can't always get that, but I'm having some trouble with like right where to hold this, so I apologize if you're getting my breathing. So why all this technical stuff? Because this is my obligatory DevOps slide. Like, you can't just build this stuff in a, that's my obligatory DevOps slide, right there. Because you can't just build this stuff in a vacuum. In order to really find success with the work that you're doing, you actually need to have at least communication. You don't necessarily need to be working in cross-functional pods of people, but you need to be communicating and collaborating, at least across teams. And I think that's really important because a lot of what you do with a pipeline is it defines your social contract, right? It reinforces it. It's not the police, right? So this is my thing on the pipeline. I'm not your mom. I'm not the police. I'm not anything, right? As a consultant, I cannot count the number of times that I have been asked, how can I keep somebody from doing X? And my answer is always, why do you want to? Because just because we're writing automation for pipelines, that doesn't make us the police or their mom or their dad or their parents or the person they call on Saturday when stuff doesn't work, right? So I'm famous for my stance on never wanting to be ops and never wanting to be tech support for my teams. I like to think of us as equal cross-functional members of teams. And the important part of all of that is that the pipeline is there to reinforce your social contract. Your social contract is something that everyone agrees to together as a team or a collection of teams. And if it doesn't work, you figure out why and you fix it. But in general, you're not the parents, and you shouldn't have to be. These are some of the things that I like to build into a pipeline. I'm probably going to have to go really fast. I don't actually have a clock, but I have a lot of slides and a lot of things to talk about. And we will have a good breakout session if you want to ask additional questions after or look at a few things. So I'm going to probably flip through stuff really fast. These are some of the things that I've built into the pipeline. These are Slack messages. I mean, you can do it with just about any chat program, really. This is some of the dashboarding that we have. This is the Blue Ocean plugin for Jenkins up top that shows all of the different stages that things go through. This is the more traditional stage set up for the multi-branch pipeline, which you will see. You can see all of the different things that we run through as we go to production, right? So we set up and build, which I have some slides on later on some of the details for these early stages. And after we run through and validate and package, we also have Sonar code quality. And we deploy, we run dev validation tests, which are a combination of smoke tests and API tests, depending on whether we're talking about feature branches or master. We archive, we have smoke tests. We have what we call journey tests, which I'll also go over in a little more detail later. And then the same thing. In stage, we run smoke tests and journey tests, and in prod, we run smoke tests. We have up on a monitor in our area. This is the collection of microservices as of maybe 2 weeks ago. I think we have a few more now. This project is pretty big. It's got at least 5 project teams right now running on it. So we have a lot of stuff going on, and we're continually making new microservices. Why do we call this duct tape and string? Because I truly believe, I'm not famous for saying it, but I say it a lot, which is I truly believe that you can make any pipeline tool work. Some of them are actually harder to make work than others, and some of them don't make nearly as many pretty pictures. But you can do it with anything. You can do it with bash scripts, although I don't know why you would want to. At their heart, pipelines are just a series of tasks that you string together with code. It's okay. And I've had a lot of folks really angst over what tool to use. And in general, the answer is just use one. And I used to say the same thing about configuration management, even when I worked for Chef. It isn't really which one you should be using. You should just use one and get going and start learning and figure it out. And then you can start making decisions around stuff. So on our internal accelerator that we actually have pipelines for Jenkins, Bitbucket, and code build. And I've done a little dabbling with the code pipeline stuff as well. And we use those specifically because they have a low barrier to entry, and they're easily accessible, especially because at least one of them is actually part of one of the code repos we use. So my next project actually that I want to do once this talk is done is I actually want to start taking our internal microservice project that we have and running it through the paces of several different online pipelines to see just how they feel, so that I can actually have several different things that I can use. This is our pipeline. I'm not sure if this is visible, if this is really easy to see. It's kind of tough. This is basically what we do from a high level in each of our environments. So we have feature branching, which is its own environment really, and then we have dev, stage, and prod. So the interesting stuff really happens in feature and dev for the most part, because that's really where all the action happens, because once that works, stage and prod are really just places for the app to live so that other things can interact with them. So when we do feature branching, we actually, once we've built stuff and run unit tests, we have what we call our test infra, which is part of our journey, or our API isolation tests that we run. And so we actually package the app, and then we package a collection of isolated microservices so that the app is testing against basically nothing real. So what that does is that allows the app to make assumptions about other services without other services being responsible for that app's assumptions. And we do that with feature branching because once you've reached the end of your feature branch, it should be nearly like the master build. So once we do that, if it passes API isolation test, it goes to dev. We do the same thing again with a master merge. And after we run unit tests, we archive, we create artifacts and archive them. And we deploy it, and then we run smoke tests, which are basically small, non-destructive tests to make sure that the app is up. And then we run what we call journey tests, which are tests that live outside the application repo that touch all of the application, the microservices that we use together. And then if that actually passes, we run Sonar Cube reporting, and then we hit our other environments. How do we do all this? This is kind of, it's not really secret sauce because it's not a secret. We have what we have internally called our microservice accelerator, and it's a project that we've been internally crowdsourcing for about 2 years. It's a fully functional AWS SAM project with several different kinds of Lambdas and communication tools, and the 3 pipelines that I told you about, and our test scaffolding, which is what the test infrastructure that we talked about. There's nothing really mysterious about the internal accelerator. It's really just something that we put together that we use as like the incubator for new projects. But it's really helped us iterate and grow from the original beginnings. It kind of looks like this. The slides will all be published later if you actually want to see. This is really just a really base CloudFront UI, and then a collection of services in the background. And I just kind of included it to show you how it would look from an infrastructure diagram perspective. But in general, this is what we care about. What's in the box for the microservice accelerator? Source code, API tests, our management scripts, because we use TypeScript and JavaScript, so we have NPM management scripts, which are like bash scripts with ampersands. endless ampersands. We have the real core of the project, which is the microservice SAM YAML, and that's basically a CloudFormation file, which I will hit in a second here. And then our different pipeline collections. So this is what we call, the accelerator becomes the starter for all our new projects. No. I seem to have lost my bullets. Oh, because I have Leon's. This is unfortunate. I will just tell you about it from memory because we actually have 2 different laptops and I edited this slide after we finished. Microservices are like ants. There's never just one. So what you want when you start a microservice project is you want your incubator, right? You need the thing that you will build all your future microservices from. And we started this on a project last summer and I didn't really like it, because it kept getting stale and people would copy it to make a new microservice and then the microservice wouldn't work and then we would have to figure out why it wouldn't work. And it turned out because somebody had updated the microservice starter and not really tested to make sure that it actually worked. So I was like, y'all, if you want to have this thing, I'm gonna slap a pipeline on it. So I did. We put a pipeline on the starter service. The starter service becomes the incubator for everything after that. And you know what else it is that's really cool? It's the place you test the pipeline, because there is nothing worse than testing your pipeline on somebody's live microservice, because that never works. Never turns out well. So anyway, that was pretty much what I was about to say about this, and I had some great bullets that pretty much said the same thing, but meh. So the microservice descriptor, aka the microservice SAM YAML. So the way we use AWS SAM is that it's basically CloudFormation with some transformative sugar on top. We use parameter inputs for some basic information pieces for environment, release version, service name, feature branch. And this allows us to do a lot of naming stuff inside both the CloudFormation and inside the pipeline itself. So what we do is we pass in those parameters, and then it allows us to do a lot of naming things. As you can see here, the function name, that's actually a Lambda function name there, and it's completely unique, even if you have 2 or 3 environments in the same account. Same thing. So the other example here I have is from your base path mapping for API Gateway, right? So the way we do it is you always have the same base domain name, and then it's your URI that unifies your application. So at that point, if I'm not a feature branch, then my service name is actually just my URI. And if I am a feature branch, it's actually my service name plus the feature branch name. Our feature branches are constructed from Jira IDs, which I will actually go over a little bit later as well if I get there, I hope. The next thing we can do, this is from our npm scripts, our package.json file. These are the core of our I can deploy things locally. So anything I can do locally, I do in the pipeline. Anything I do in the pipeline, I better be able to do locally so that devs can actually reproduce the things that I do. Same thing, they probably did it first, so I took the thing that they did and reproduced it in the pipeline. These things are really important because this gives you your homogeneity across environments, and it gives you a connection point between the people working locally and the people and what they're trying to understand is happening out in the world, right? So what we have here is what I call our package deploy, and I was going to show you what this looked like in CloudFormation, but this is not my laptop, so I lied. I'm not going to show you. But what this basically does is it creates the concept of a feature branch as name. Oh man, 10 minutes. All right, I'm just gonna have to go really fast and you can maybe see my slides later. But conceptually, my name is the feature branch name, and then I can deploy a stack to CloudFormation in AWS, and then I can actually run API tests against the thing that I just deployed, which is really awesome. And we use basically the same construct later to deploy things in the pipeline. This is the Jenkins file you'll find in the app. The app has nothing. The point of the Jenkins file is to be a pointer to an actual collection of Jenkins file code elsewhere. Because again, you want to build like you're going to have 30 microservices, and the last thing you want is to have duplicates of your Jenkins file everywhere, or your build spec, or anything else that you're using to define how things work, right? So we do almost nothing in the Jenkins file except tell it where to find the library and then which library file to invoke, in this case, the TCE service pipeline. That's the feature branch build from earlier. I'm going to run through tests real quick. We employ several types of tests. We have unit tests, API tests, journey tests. We also have smoke tests, which are not covered in here. Basically, this is a holistic coverage collection. And I actually plagiarized these slides from a colleague, which is why they don't have the nice theme on it. So what are you going to do? So unit tests, we have lots of these, right? So every Lambda we write has several unit tests. We have lots of unit tests and even more unit tests. The unit tests are the foundation of everything that we do. We have a lot of coverage requirements around them, and we report them to Sonar later as well. So that's the base, and then every service has them. We have API tests, and this is what I was talking about with our isolation testing. So conceptually, we have a service. API tests call the service to see what the service will do. The thing that we have to avoid is the service making assumptions about other services, because right here, this is the beginning of microservice spaghetti, and you will hate your life if you start actually depending on other services to respond appropriately during your API tests. There are ways to get around that. We wrote our own. There are other things out there that you can use, I think. But conceptually, what you want to do is keep your API testing as isolated as possible, because the second you start making assumptions about what's going to happen, nothing will work. And you will have cascading dependencies that will make you really miserable. So we wrote something internally. Currently, it was called originally Andrew's test scaffolding because Andrew championed and wrote it on a project last year. And we have renamed it to just test scaffolding. Okay. But basically what it does is it sets up this isolation. We deploy a second stack with our feature branches. And it allows you to actually pretend that you're calling external microservices when needed. So the second CloudFormation file actually defines resources necessary for isolation of services. And then I'm going to race through these. Basically, it sets up a thing where it calls the service has a thing that it has to call. Instead, the test scaffolding defines a fake Lambda that subscribes and writes a message to a DynamoDB. And then we actually, once we do it, we call Dynamo and say, what happened, Dynamo? And make decisions on whether or not the test passed or failed based on that information. Same thing, service subscribes to external SNS topic. We don't want to have to actually call somebody's SNS to find things out. So same thing. We mock things up and create mocks of the things that it wants to call. And it does the things and the stuff, right? So I'm going really fast because I'm going to get in trouble here really soon. So these are really great. Conceptually, what I wanted to share was the idea that you really want to try and isolate your API testing when you can at the microservice level. And what do we do to deal with the fact that we still have to make sure that our services actually can work together? We'd have journey tests. So this is an actual diagram of stuff that we're working on, so I actually had to go through and black a bunch of stuff out. I'm sorry, it's not very pretty. But conceptually, what we want to do is talk about the idea of all of the services work together. How do we know they're actually going to work together now that I know that my service does what I think it's supposed to do? So what we have are journey tests, and we test things across our entire system of microservices. In general, they might mock or spoof externals that we don't own, because we have a few of those. So, but they're not test scaffolding. They actually live in their own separate repo. So every application, every microservice that has a pipeline, when it actually deploys to dev and deploys to stage, it then checks out a separate repository for journey tests, and it runs the journey tests. All of the applications run the same journey test collection, which is really hilarious on days when I'm just gonna, some days, the struggle with journey tests is when the journey tests are broken, everything is broken. So we struggle with that a little bit. We're still really getting good at this concept of holistically testing everything. After journey tests, we also have smoke tests when an app comes up. They're non-destructive, lightweight, just to make sure that the app is responding appropriately before we start running serious tests. We also ship to Sonar, which I've mentioned a couple of times. And someday, I hope, we're going to have production verification metrics and reports, but we aren't actually quite running real production yet. This is what happens in dev. This is kind of a blow up of the feature branch dev slide collection. And I really wanted to talk about it in detail, but I'm not going to because I'm in trouble because it's 5 minutes. This is kind of an example of what I'm talking about. So with feature branches, one of the first things we do is verify that you actually have a JIRA ID attached to your feature branch name. If you don't, the build fails. And this is the message you get. And here is the example code from this. I just wanted to show you a little bit of how we do stuff. So this is actually from the TCE service pipeline. The first thing we do is we look at if this is a feature branch, we call the function called validate feature branch name, pass it a couple of variables, and then if it comes back okay, then we set up the feature ID, which is basically TCE-some number, which is straight out of JIRA, which means that we have a trail to actually trace every JIRA story that we work on. And then this is the validate feature branch that we called, right? So basically it says, give me a couple of pieces of information, and then I'm going to do a regex on it and say the branch is working. Otherwise, it doesn't look right. If it doesn't look right, start over, try again. No, wrong button. Things that we don't have yet. We really want to write AWS config rules so that we can actually help people construct things properly, right? So we have certain things like encryption at rest that need to be configured on several items, but all of the devs don't always know that. So we're hoping to actually set that up in the next few months. Security scans, we don't really have too much of that. Plus, it's different for every client. So our client last summer was using Black Duck. My client now is using Black Duck, but they don't want to. So we have like a gap in there right now of how we would like to be doing things. Infrastructure is code that isn't CloudFormation because nobody actually likes CloudFormation. I don't really enjoy it. I actually had this great wish that I could write CloudFormation in the CDK, but that will be maybe the next project I can start out that way, but this project, I'm still stuck writing CloudFormation for the foreseeable future. And we still don't have any blue-green canary deploys for our production stuff, so that's probably gonna be summer project number 2, is getting that going for the most part. So that was really super fast. I'm sorry that I had to race through it so fast, but we will have the slides published, and we are going to have a breakout session. So, and I'll be around the rest of the day if people want to talk. That's really the end of everything. So thank you. Thank you for coming. I really appreciate it. I haven't done a conference talk in like 3 years, so.